Alright guys, this is Unit 2 Equations. Unit 2 Equations. In this unit we will begin to determine the ways to solve equations. One of the other things you'll be doing, you will also examine the appropriateness of results with one-step, two-step, and multi-step equations. You will also begin to see that equations may have more than one solution, while identifying and describing mathematical processes precisely with the properties of equations. Lastly, you will begin to solve equations with more than one variable term. So just looking at an overview of this unit, this is the page numbers. And then the next page, it tells you that you have 1, 2, 3, 4, 5 lessons, a unit review for Unit 2, and then the unit test on the 4th and 5th. Okay? Now, the first lesson in this unit is one-step equations. So, for one-step equations, the inverse, it's just the opposite of something or a thing that undoes something else. So, the inverse of 2 would be -2. The additive inverse, that is. The reciprocal, on the other hand, it's just the reciprocal of a number is produced by flipping it over. So if you have a whole number, you want to identify the reciprocal of a whole number by creating a fraction and dividing by 1. Then you flip the numbers over to produce a reciprocal. So for example, given A, technically A also equals A over 1. The reciprocal of A is 10 over A. So what is the reciprocal of 10? Well, 10, I have 10. I'm going to transform it to 10 over 1. The reciprocal of 10 over 1 is 1 over 10. Now, if you already have fractions where numerator is 1, for numbers where numerators are 1, you will always produce a reciprocal that is a whole number, or that turns out to be a whole number. So if I have 1 over a number, so 1 over A, the reciprocal is A over 1 or A. Similarly, if I have it says, what is the reciprocal of -1 over 4? Well, if I flip it over, it becomes -4 over 1, or just -4. Now, for all other fractions, we're simply going to flip it over. There's no trickery, no further need to go any deeper than that. So for all other fractions, you simply flip the numerator and the denominator to produce the reciprocal. So, given A over B, the reciprocal is B over A. What is the reciprocal of 2/3? It's 3 over 2. Now, next part, we're going to talk about inverses and types of inverses, and how reciprocals and just plain old inverses fit in. So, an adding inverse or additive inverse is just a number's opposite. So, a number and its inverse in addition equals 0. You add two numbers together that are opposites, it equals 0. To do the opposite of addition, you subtract. Given 3, the opposite is -3, because 3 minus 3 equals 0. So what is the additive inverse of 5? It's -5. The proof is 5 minus 5 equals 0. A number and its inverse in subtraction equals 0. To do the opposite of the subtraction, you add. Given -4, the opposite is +4. So -4 plus +4 equals 0. What is the opposite or the additive inverse of -7? -7 plus 7 equals 0. So the inverse is +7. Now, for multiplicative inverses, you're going to be using the reciprocal. So a number and its inverse in multiplication equals 1. To do the opposite of multiplication, you divide or multiply by the reciprocal. Given 2, the opposite is 1 over 2, because 2 times 1 over 2 equals 1. Given -3, the opposite is negative 1 over 3, because -3 times negative 1 over 3 equals 1. So a number and its inverse in division equals 1 as well. To do the opposite of division, you multiply or use the reciprocal of a fraction. Okay? Moving on. Alright, so now we're going to get into one-step equations. So for one-step equations, when you add, subtract, multiply, or divide a number with x, you use the opposites or the inverses. You use the inverses to solve the equations for it. So we're gonna stick to a couple of rules here. First, we're going to rewrite the equations that are given. 2, we're going to identify the number and the operation and solve for x by doing the inverse of the number. 3, when adding or subtracting, draw a line underneath all operations, and the results go below. So first, for adding a number from x, you're going to be doing the opposite of adding. You're going to be subtracting that number from both sides of that equal sign. Okay, so I'm going to rewrite the equation, x plus 2 equals 5, and draw a line down the middle. Okay, now if I'm solving for x, that means I'm not going to do anything with the x term, it's just going to sit there. Okay? Now, I'm going to subtract 2 on both sides. And then the x comes down, this goes away, equal sign comes down, and 3 comes down. And then I can check my answer. Is 3 plus 2 equal to 5? It's true, so I'm done. My proof is there. Okay? Now here, the next one, I'm going to rewrite my problem. 5 plus x equals 9. Draw my line down the middle. And then I'm going to highlight my x term. It's not moving. My variable term. I'm going to subtract 5 on both sides. This goes away. X comes down. Equals 4. Check my answer. 5 plus 4 does equal 9, so it's true. For the last one, I'm going to subtract 10 on both sides. X equals -3. -3 plus 10 does equal 7. This is true. Okay? Now, for subtracting the number from x, the opposite of subtraction is adding. So I'm going to add 2 to both sides. But remember, if you do that yet, you got to rewrite the problem. Add 2 to both sides. Draw my line underneath. The results go underneath x. This goes away. 2 minus 2 is 0. Equal sign comes down, and that's 7. Okay? You can check your results. 7 minus 2 does equal 5. So it's true. The next one, rewriting my problem, -5 plus x equals 9. Maybe you still need to highlight. That's fine. Okay? And then add 5 to both sides. And x equals 14. That goes away. Okay? Last one. Have x minus 10 equals 7. Add 10 to both sides. I get x equals 17. All right? For multiplying a number by x, you're going to use a reciprocal. Or divide. I like reciprocal better because it's always safe. Can't go wrong, but we're going to divide. Now, the opposite of multiplying here is dividing by a number on both sides. We're doing the opposite. So it says 2 times x equals 8. So I want to get the x term by itself, so I'm going to divide 2 on both sides. And I'm left with the x coming down and 4. And then you just check your answers. 2 times 4 equal to 8. Yes, it's true. This is true. Okay? Now, the next one, I have negative 2 times x equals 8. I'm going to do the opposite. So I'm going to divide by negative 2 on both sides. And x equals negative 4. Check my work. Negative 2 times negative 4 does equal a positive 8. Last one, 4 divided by 4x divided by 4, and then 9 divided by 4. 4 is canceled, and I'm left with x equals 9 over 4. Okay? Check your work. 4 times 9 over 4. This cancels, and I'm left with 9. So it's true. When you're dividing a number by x, you put it in fraction form, and you use the reciprocal. The opposite of division is multiplication. Typically, you only need to worry about reciprocals when you're thinking in terms of a numerator, like a fraction where a numerator has a different number other than 1. Okay? Otherwise, you're just multiplying. So here, I have x divided by 2 equals 8. So what number divided by 2 equals 8? Multiply 2 on both sides. 2's canceled, and x equals 16 is your final answer here. For the next one, negative 1/2 times x equals 8. You're multiplying by the reciprocal. So negative 2 over 1 on both sides. Multiply. 2's canceled, 1's canceled, negatives cancel out, and I'm left with x equals negative 16. Final answer. For the last one, we have 3 over 4 times x equals 9. So rewriting. I'm going to multiply by the reciprocal. 4 over 3 times 3 over 4. And then on the right-hand side of the equal sign, 4 over 3 times 9. These cancel. X comes down. 9 times 4 is 36. 36 divided by 3. Okay? All right, for this section, it's word problems. And you made a lot of mistakes on the test because of, I don't know, words you were using. But here, this is a plus sign. I don't know how that's confusing. That's a plus sign. This is a negative. You don't put -5 in front of when there's a negative in front of a number. So here, x plus 2 equals. If you put the equal symbol in a written statement, I'm going to mark it wrong. Equals -5. Go ahead and do number 1 through 5 on the top, 1 through 4 on the bottom. Take 2 minutes. Take 2 minutes. Do 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Yes.
So we can put equals in a written statement.
You cannot write equals in a written statement. You need to write it out.
Oh, never mind. I get it.
Instead of equal, can you write A?
You can use is. It's shorter. Take about 2 minutes. If you use less than, make sure you switch. Check your answers. If you got something different and you're unsure whether or not it's right, let me know. You could have said for number 2, B is less than 4. And it would have been really good. Can you rest? If you wrote 1 half, it's wrong. Write it out. Write it out. Do the bottom 4. Take a minute. When you're translating to words. So, do number 1 on the board. Number 2, Fernando. Number 3, Kathleen. Yeah. Half of x. You can put x divided by 2. Hurry up. Come on, Sal. You can do it. What's the number?
X
What's increased by mean?
plus
Plus what?
M.
Go ahead. Perfect. All right. What does that say? Okay, 2 times x equals 10, guys. Come on, bud. Jennifer, come on. Number 4.
No.
Okay, what's wrong? The last one, number 3?
Yes.
Why?
Same thing.
Wait. Tell her. Say Jennifer.
No.
It was her.
Wait. Doesn't matter? Kathleen, ask them what's wrong with yours. Ask them. Say, what's wrong with my stuff? Tell them. Ask them. What should she write? So she has to switch, right?
Yes.
You need to be like classmates and let her know. Go ahead and fix it, baby. X minus 5. That's fine. Why are we doing this? So you have better grades on the tests. It's okay to be wrong. It's okay to correct people. You need to understand that. No, we're about to do the bottom part. Next part. Here, Mary's age. We're gonna have to think of variables. We're gonna have to think of numbers, and write actual equations. So what's a good variable for Mary's age? M. Mary's age. What is equals? What's half look like? You can divide by 2, or you can write a fraction. 1/2 times what? What's a good letter for Tom's age?
T.
Try number 2 on your own. Think about what increased by means. Find your equal sign. Write it right above so it's equal. All right, number 2. What does increase by mean? Right there. What does increase mean? Increase the distance.
Addition.
Addition, you're adding. So you're going to put a plus symbol here. You're adding what? 12. And you're going to write equals. Equals what? What's a good letter? B for Barb. What's a good letter for 1? J. All right. So the next one I will tell you is a multiplying problem. Every means multiplication. You're timesing things. Or an inappropriate way to say it, but you're multiplying things. So every 4 bottles of water that Avery drunk equal the amount that Lord drunk. So I'm going to write a phrase, write an equation here. So 4 times what? What do you want to use? A. 4 times A, you can do 4A and just put them together. Or you can do a symbol, equals L. Next one, number 4. Harry is 4 years younger than Francis. So H equals 4. Is that right? What does younger than mean? Less than. So you switch. Be careful. F minus 4. Now the next problem is a perimeter and area problem. So the perimeter of a figure, you just add all of the things around it. The length, the width, the other length, and the other width. But for the area, you're just multiplying the length times the width. Okay? So you're going to draw a figure here. Draw your rectangle. Is the length going this way or this way? Does it matter?
Length goes this way.
Does it matter though? Not really. But this is x plus 2. The other side is x plus 2. And then the opposite sides are 10 and 10. So if I want to find the perimeter, I just add the whole thing together. Add all the sides together. P equals 10 plus x plus 2 plus 10 plus x plus 2. How many x's do I have? Go through and circle them. Circle your x's. Circle your x's. 2 x's. Circle them. You guys didn't do so well in combining like terms. Everything else are just numbers that you can add together. So I have 2 x's. What's 10 plus 2? 12 plus 12. And 10 plus 2 again, plus 12 plus 12 plus 12. 24. Here's my final answer. Can you combine these 2 terms? No, they're not like terms. That's your final answer. That's it. That's your perimeter. Your area, on the other hand, what's the length of this triangle, this rectangle? 10? What's the width?
X plus 2.
So 10 times x plus 2. What do we do with that 10? It distributes to the first term inside. What's the first term inside? 10. It becomes 10 times x plus what?
Okay.
Skip the step. That's okay. Plus 10 plus 10 times 2. Come down, simplify, you get 10x plus 20. Circle your answer. You distribute. Flip the page, we're going to do 2-step problems. And then you're going to do the notes, and I'm going to pass out your test. You're going to come ask some questions if you need to. So 2-step equations have 2 steps to solve. So far, we've only been adding or subtracting, multiplying or dividing. Now you're going to add and subtract, and you're going to multiply and divide. So 2 steps. First, you always add or subtract. What's your first step when you're solving a 2-step equation? Carla? What is your first step when you're solving a two-step equation? Yeah. What else? Or? So you're adding or subtracting a number, guys. The second thing you're probably going to do, the major things, not these repetitive things you have to do, but the major parts of a two-step problem. You have to add or subtract, and then second, you have to either multiply or you have to divide a number. That coefficient in front of x, you're going to have a number in front of the x term now. So we're going to follow the same steps, but first, the opposite of adding is subtracting a number. The opposite of division is multiplying. A little refresher. Now rewrite your equation. 2x plus 3 equals 15. Highlight the 2x. Am I going to touch that first? No. What am I going to do first? Add or subtract? Can I add or subtract? Yes, Sam? Subtract what? 3. Draw your line down the middle. Subtract 3 on both sides. What'd you get? 2x. What happens? Comes down. 3 minus 3 goes away. What's 15 minus 3? 12. What's the second step? I have 2 times x. Divide by what? 2 on both sides. And x equals 6. Who needs a piece of paper to write these steps down on? Who doesn't have something to write? Do number 2 if you got something to write. Rewrite the equation. Look at it here, right? Look at it. Number 2. So I'm going to rewrite my equation. I'm going to do it on another sheet. Okay? So I have 5 plus 2x equals 9. Highlight your x term. Did you move it? If you did, it's wrong. What number are you messing with here? 5. What do you do to 5? Subtract it from both sides. If you can't tell what both sides of the equal sign are, you always put a line down the middle of that equal sign. Get your head off the desk. Subtract 5 on both sides. 2x comes down. Equals 4. What you do after that? Divide by 2. Good classroom. Yeah. Hurry up. Alright, so I'm rewriting the problem. I have 3x plus 10 equals 7. What should I highlight? 3x. I should highlight the x term. It's not doing anything at first. But what do you do first?
Draw the line down.
Draw the line down. I forgot to do that. Then what?
Then move the 10 over. Minus 10.
Subtract 10 on both sides. Do I just do one side?
No.
No. Who's going to mark it wrong? Okay. 3x comes down. Equals -3. What did you do after that?
Divide by 3.
Divide by 3 on both sides. X equals -1. Have one solution there. Let's look at the next one. What's the opposite of subtraction?
Addition.
Write addition. Write a plus sign. What's the opposite of division?
Multiplication.
Put a dot or put MU something. Now, look at your first problem. Go ahead and rewrite it. Go ahead and rewrite it. I have 1/2 times x minus 2 equals 5. What do we want to do first?
Subtract 2. I don't add 2.
Add 2. Add 2. Don't just yell out answers. You're going to confuse people. You don't want to confuse people. You're already confused. That's going to piss me off. Or tee them off. One of them. Hi. Oh, close my door. Close my door. Close my door. Close my door. Okay, so we added 2 to both sides, right?
Mm-hmm.
You guys feel good about this?
Yeah.
Yeah, I hope so. 1/2 times x, this goes away, equals what?
7.
7. What do we do with that 1/2?
Bring it down. Flip it over.
Why do we flip it and not bring it down?
Reciprocate.
Reciprocal. We're not adding this, we're multiplying. So 2/1. Both sides, guys. 2/1. Multiply 2/1 on both sides. You flip it over, multiply it. This goes away, x comes down. What's 7 times 2?
14.
Over what? 1 or just 14? Or just 14? I'm gonna skip the next 2 to the right and drop down 1 to 2x minus 2 equals 8. Does everybody see that? 2x minus 2 equals 8. We're gonna do that one. 2x minus 2 equals 8. So before we move on, what's the opposite of subtraction?
Addition.
Put a little plus sign there. What's the opposite of multiplication?
Division.
Here, I'll do mine. Plus division. Okay? Now, what did you highlight? What would you highlight here? 2x. And then you said put a line down the middle, right?
Yeah.
What do we do to both sides? Add 2 to both sides. Perfect. Two x comes down. This goes away. Equals 10. What do you do after that? Divide by 2 all the way across. So I'm going to call you up. We're going to look at your test together, guys. And we have x equals 5. Final answer. Okay? I want to do the one below that as well. It's x over 2, or half of x, minus 4 equals 8. may not know where we're at. We're just doing the first set of problems on the column. Okay? Rewrite the problem. X over 2 minus 4 equals 8. What am I going to do first? Add 4 on both sides. X over 2 comes down. This goes away. Equals 12. Why do I get rid of that 2? Multiply 2. It says x divided by 2, so I'm going to multiply by 2. This cancels. X equals 24. Please do your classwork. Get started on your classwork. I'm going to call you. And when I call you up, even if I've already called your name or showed you your test, when I called you up, bring your classwork so I can see it. Bring the classwork that you have right now. Your classwork. Yes. Start at the very top. It says, what is the opposite of addition? Yeah. Yes.